Hey, welcome to You Choose, a choose your own adventure style journey through the CNCF landscape. And we're on chapter 4. We're deep into chapter 4 now, talking about observability. So last week we talked about traces. What did you learn about tracing last week?
Without traces, you have no idea what's going on the networking layer within your application, right? Unless you have one application, then nobody cares.
Unless you're just so when I think about tracing, I think about like one request like bouncing all around the system to different machines and different services, and being able to keep track of it as it goes.
That's it, right? How to track. I mean, you don't need traces to track requests. What you need traces is to connect different requests into one path.
Right. So you can think about it from the point of view of an individual service. Like they receive a request, they attach a span to it, and then when that request leaves that particular application, then that span is created. Yeah? Is that how it works?
Yeah, I mean, it's like pinball, right? Kind of, imagine the request is a ball, and then you, poof, it goes there, and poof, it goes there, and then, and finally gets out.
I was trying. Perfect. Okay. But I have been trying to think about it from the application layer, from the like this, a span is created. Is that span follow the request around, or is the span itself independently
span is a part of it, right?
Right.
Single request can be a span, or parts of a request can be a span, and then that application sends another request that is on a first look completely unrelated, right? But it is followed by, right? So all those requests from one application to another, they are technically separate requests, right? Unrelated to one another. But then we inject some identification to them and say, okay, treat this second request as actually it's part of the first one.
Yeah. So all the spans somehow are stitched together into a full story of what's happening.
Somehow.
Magically. But okay. So the goals of tracing, you're like, this is the only way for you to understand what's happening in your distributed system. Is that?
I mean, both on a more global level, where do the things go, but also on lower level, say, this part of it, how long did it take, right? Or what's the error message, or whatever you're outputting.
Metrics are kind of like a zoomed out view. And then with traces, you can zoom in and understand like individual behaviors better. Is that accurate? You can say that
traces contain some metrics and some logs, right? Mm-hmm. Not all the metrics, you need much more than that, so it's not replacing your metrics. But hey, like the time, the duration of a span, right? That's effectively a metric.
But like if you know something is going wrong, a tracing is a good way to figure out what exactly went wrong. Of all the different services a single request touched, which one is the one causing latency? Tracing is good. How you're going to figure that out.
The way I see it, you're likely not going to use tracing to find out that there is something wrong. You're probably going to go on metrics and see stuff. But then once there's something wrong happening in a system, then you start digging deeper into metrics, deeper into logs, and deeper into traces, depending on what's going on.
So here's a question. So surprise. So like metrics, because Prometheus is ubiquitous and your third-party stuff is already instrumented to emit metrics, they're like handed to you on a silver platter, and you just have to take them. Like tracing seems harder. Like you actually have to instrument your applications to emit traces. First of all, is it harder? It's not harder.
So not necessarily, right? You can, depends on the language of your application, you can add traces automatically as a sidecar and say, hey, this is some JavaScript, something, add traces to it, right? Automatically, automagically.
Okay.
Then you can use libraries within your application that are already instrumented. So let's say you're implementing a web server or server of sorts, and you're using Gin, which would be one implementation for Go, and then you can actually, Gin comes with instrumentation if you choose to use it, right? Or you can go deeper and say, you know what, that's too generic for me. I'm going to add a span exactly in this part of my function, right? Because that's the level of detail I'm interested in, right? So it goes in different. So whether how much you need to do and what you need to do depends on how deep you want to go.
How much information. So do people instrument, how well used is tracing? Like if you're doing observability.
Not very well.
Like not very many people are doing tracing. Like it's pretty common to do metrics. It's maybe common to think about logs, but is it common to utilize tracing?
If I would order those three based on commonality, I would say that the first place goes to logs.
In terms of how many people are implementing them.
Yeah, kind of like
capturing them. Yeah.
Yeah, you're writing something to logs. Most likely. That's 99.9%, right?
Okay.
Most likely too much, and most likely you forgot to disable debug mode that spits out every single detail and crushes your system, but you're doing logs, right? And then you're doing metrics second, and then you're doing traces. I'm not saying that that's the order it should be, just to be 100% clear, but that's usually the order, at least in my experience, of adoption. Which happens to be inverse order in OpenTelemetry.
Like if you're implementing OpenTelemetry, you're probably implementing traces.
OpenTelemetry itself advanced further with traces, at least back in a day, and then metrics followed, and then logs for the last to get serious thought and implementation.
OpenTelemetry started as open tracing. We learned earlier this
season. There we go.
Yeah. So something I learned last week is that the most expensive part of implementing traces is the storage aspect. There's quite a bit of talk about filtering and downsampling.
You can say the same thing for any part of observability, right? Metrics can be expensive depending on how crazy you go, and logs can definitely be expensive, right, as well. Now, I'm not saying that one is more expensive than the other. Depends on what you're doing, how much you're doing it. But all those things can be expensive, both on networking and on storage.
And that's part of how the data pipelines we'll talk about later. That's one area they can help.
Is that the subject of today's session?
Victor is prepared. Also, we probably should have said that earlier than right now. But yeah, it's in the title. you know, you're here. But before we talk about data pipeline or collector type stuff, we need to go over the two technologies that we talked about last week. So we had a representative from Jaeger and a friend from Zipkin.
Yeah.
So what's the difference between Jaeger and Zipkin?
One is older than the other. Zipkin is older than Zipkin. Than Jaeger, yes.
Yeah.
So kind of, with age comes pros and cons. The older you are, the more battle tested you are, and the newer you are, more of
flashy.
The experience from the other one you could have implemented from the start.
That's a nice way to put it. So Zipkin is older. It was designed for Java applications. It's written in Java. If you're using Java, maybe Zipkin's a good idea. It also...
I mean, no. If you think that using Java is a good idea, then Zipkin might be in the same box.
If you're trying to trace your legacy applications, Zipkin probably has an instrumentation library ready to go for you, right? I'm not going to say mean things. And then so Jaeger has a nice UI. Jaeger has a better UI.
Yeah.
But they both do traces, and they both do traces well. But Jaeger has tight integration with OpenTelemetry. So Jaeger used to have its own agent, its own SDKs and stuff, and now it doesn't. It's like, now we'll just use OpenTelemetry SDKs to get our traces into Jaeger. So they're almost one and the same in my mind. And then Zipkin has a ton of libraries. So those are the main differences. They both seem to do tracing just fine and do it well. I don't think there's any real difference in that part of it.
No, they are very, very similar. I mean, of course, there are differences, but nothing to write home about.
Yes. So we had some voting in our You Choose channel in the CNCF Slack workspace.
Oh, yeah, it's somewhere. Where did I put it? Wait. It's somewhere. This is me building the tension. There we go. Yeah, Jaeger won.
Jaeger won.
And that means that I need to do now my Jaeger dance, right?
Yes, your Jaeger dance.
yeah, there we go. It's going to be relatively easy. So, so here we go. If I show you my application, you will see that this is the pod of my application. And the only important thing here is that there are 2 out of 2 containers in that pod, meaning that there is a container of my application itself, and there is a sidecar container that I added, and you can do it yourself by going through the repo that basically emits OpenTelemetry. And now we're going to see whether Jaeger picks it up. And to do that, I'm going to execute hey. This will be sending, 5 minutes is too much, 2 minutes of traffic to the application just to see it up and running or to generate some traffic. And here is the application. Sorry, not the application. This is Jaeger essentially. Now, I don't have a fancy setup, so you will not see a lot because it's a single replica application. But if I change to demo, and click traces, you will see the traces of my application, right? These are different requests that are coming. Now, since I'm sending requests, bombing it with the same request, you see basically get to the root all around, but you need to use imagination to imagine that you will see gets and posts and puts and delete requests to different endpoints, to different paths, and so on and so forth. And you will see all that also on a graph, which essentially, at least this one shows the time when something is happening and the response time of the requests. And you see the darker one here. This is probably when I started bombing it, right? And it's going on now. And I can go to any of those traces. I can see, hey, this is how long it takes. This is what it does. This is all the information about the trace. Again, I don't have a large system here, so you don't see all the different spans. It's a single span. But that's the information, the tags and this and that, and the process that generated it. And you can figure out who is destroying your weekend by killing your system.
Yeah, let's implement tracing so you can blame people for problems.
Yeah, because the big part, probably the most important part about observability is to be proficient enough at it so that you can find out whom to blame.
Perfect.
The job description of person dedicated to observability is finding the culprit and blaming them publicly.
Whatever you can do to humiliate and shame them. And bonus points if their family is shamed too.
Exactly.
I think the important thing to say, what Jaeger is doing is getting data from OpenTelemetry SDKs, and it's putting that data into storage, and then it's exposing that data to the query, to the UI that Victor just showed. And that's basically what it does. Bing, bing, boom. And there are ways to think about how to scale it and how to drop data and how to sample and whatever else. But in the end, they're just getting the data and putting it into storage and
basically, you're shipping data. You might ship everything. You might choose the strategy for shipping every tenth, or in case of errors or this or that, you choose what to ship, and it's stored in an internal database, presented through the web UI or through API, and hopefully you're combining that information with other types of observability, which is infinite amount of categories, and making something meaningful.
Infinite amount.
Finding the culprit.
We have a quiet chat today. I guess we haven't said hello to you. Hello, chat. We're about to dig in now to data pipelines. So if y'all who are here live have any questions, ask your questions as soon as possible. Then we're more likely to get to them during the question and answer part of the show at the end. Hello. Thanks for saying hi. And so first of all, when we say data pipelines in the context of observability, what do we even mean? What are we talking about?
Getting stuff, transforming stuff, and pushing stuff somewhere else.
Yeah, that's it.
That's my scientific explanation from a Webster dictionary, probably, of data pipelines.
So data pipelines are made up of a receiver, a processor, and an exporter. I don't know if they're all called that all the time.
Discard it, and that's the best option. Get something discard so that nobody can blame you. Nobody can blame you for messing it up. If there is no proof.
That's
there is suspicion.
Get it. Remove all identifiable data. Which actually gets me to my next question, which is what are some examples of pipelines? So removing PII information is actually a very good example of what you might want to do with the data pipeline.
Yeah, you could also downsample. You can format, make it structured. I don't know whether people still do that. I hope that now, for example, if we talk about logs, for example, I hope that people are outputting structured logs. I hope, right?
Yeah.
But back in my day, people were outputting...
Any old line of text.
Exactly, and then I had processes that would get that and figure out, is it this or that, and how do I extract this? A lot of regular expressions involved in that miserable part of my career.
Actually, talking about logs, at first when we were designing the season of You Choose, we had an episode around logs, and then we decided to do an episode on data pipelines.
I blame the guests.
Yeah. You don't want to own that decision? I think it seems like the technologies that used to do pure logs have now upgraded to do to be able to handle all types of telemetry data.
Depends on which part of it. We still have other tools related to logs. We still have Loki, for example, which is very good storage for logs. And we still have Grafana that can be used to query it, and so on and so forth. So there are just different aspects of it.
In terms of log collection, are there tools that collect only logs and not all telemetry
You mean
data?
store? Yeah, that could be Loki, for example.
Okay. I think in my mind, collecting and storing are separate things. But
no, sorry. Loki is storing it. Collecting, yes, there are different tools. If I go from the same family like Loki, that would be in case of Grafana, it would be, I think it's called Promptail, right? And also I guess might correct me, right? Fluent Bit can collect the logs and then also do something with them before shipping them somewhere else.
But I guess my question is there a tool that does only logs? Because what I'm saying is all the tools that used to do only logs, like Fluent Bit or Fluent D, have now upgraded.
But which part of logs?
And they do all the telemetry data and not just logs. That's why we don't have an episode on just logs.
When you say by logs, you mean collecting logs and shipping them?
Yeah, data pipeline. Yeah, yes, collecting logs. When I say do, I mean collect. Yes, sorry.
Yeah, of course. How could they not have guessed that do and collect is the synonym in English language?
It's fair. I stand corrected.
Again, that's not the area that I'm deep in, but again, back in the day, most of the tools were also not only getting logs, but transforming logs another piece of data into something else before shipping them somewhere else.
So far in the show, we've only really talked about collecting and maybe transforming a little bit. But like when we talked about metrics, when we talked about traces, we're talking about collecting. They might put things into storage, but we haven't been talking about storage because we're scoping our show to CNCF, and there aren't observability storage solutions in the CNCF.
Correct.
Yeah. So that's why in my head when we're doing logs, it's collecting, because I have it all in the framework of you choose in my head. It's all you choose all the time up in here. Yeah. All right. So we decided to do a data pipelines episode and omit a logs episode. And so our technologies today, some or all of them started doing just logs and now have upgraded to do all sorts of telemetry data.
Funky stuff.
And yeah. And what should we be thinking about when we're evaluating all the tools today? What are some things to worry about with data pipelines?
I don't want to get the air from the sails of our guests. They're going to
we do this question every week. So our three technologies, we should say, are Fluent Bit.
They're very different, right? So that's the thing.
OpenTelemetry collector and logging operator. Yeah.
Yeah, and they're fairly different, right? One could even argue whether they should be in the same category. Right?
I'm under the impression that Fluent Bit and OpenTelemetry collector are very similar, actually.
We'll find
but
out.
I think
then.
logging operator is different and adds on top of either or both. Yeah. So so when we're looking at data pipeline stuff, multi-tenancy is something to think about. Where this is a time where performance is going to be different, and so performance meaning like different pipelines I think are optimized for different signals.
Yes.
Yeah.
Exactly. I mean, it all depends how you look at it. If your primary concern is performance, then zero transformation. Just ship it directly. No pipeline, nothing. Right? That's one extreme. The other extreme are those text blobs I was talking about before.
The thing about telemetry though, like telemetry data is so vast that any little bit of performance help can make a real difference in this case. So maybe you choose your data your pipeline, your collector based on what you plan to do with it and what's going to be more performant for your particular use case, because that little bit of help really makes a difference. And then I guess there's like community, there's who's maintaining the collectors, there's how long does the collectors take to process, those sorts of considerations. And I think we're ready for some guests. You ready
Let's
for
bring
some
them
guests?
in.
Okay. First, we're going to introduce Jurasi. Hello, friends. Thank you so much for being here. Please unmute yourself and introduce yourself.
Hi, hello. My name is Jurasi Passion-Kroning. I'm a software engineer at Grafana Labs. I'm on a soulless room here at the hotel in Vienna, Austria, in the beautiful city of Vienna, Austria. We have the KCD this week, so I apologize for the scenery. But I'm a software engineer at Grafana Labs, and I work on the OpenTelemetry project, more specifically on the OpenTelemetry collector. So that's where I try to make most of my contributions. Not working out very well lately. So many other things to do at OpenTelemetry. I'm also part of the governing board for OpenTelemetry, and I'm very happy to be representing the collector here today.
Awesome. Thank you so much for sharing your time and expertise with us.
Thanks
we'll see you very shortly for your 5-minute presentation. Get ready. Gargle some water. That's what you do. That's what opera singers do, right? All right, Eduardo. Hello, friends. Will you introduce yourself, please? Hi.
Yes, my name is Eduardo Silva. I'm originally from Chile. I live in Costa Rica. I'm a software engineer at Chronosphere, and I lead the Fluent Bit project, which I created 9 years ago.
Amazing. That's so cool. Thank you for being here, and we'll see you in about 5 minutes. Bye. And last but not least, Sendor, will you introduce yourself, please?
Hi, thanks for the warm welcome. I'm Shander Guba, CTO at Oxoflow, where we actually build telemetry pipelines. But I'm here because one of my open source project called Logging Operator. I love Kubernetes. I'm an observability enthusiast. During my engineering time, I was operating global scale infrastructures. That's why, and then I really like to know what happens in a large system. So I think that's where it comes from. And today I will talk about Logging Operator and Telemetry Controller, which is my new gig.
Awesome. Did we get anything wrong when we talked about data pipelines? A lot? Is that what that means?
It was more than right. Yeah, I think we will have time to talk about it a bit later.
Awesome. Cool. Well, we'll see you soon. Thank you. All right. Are you ready with the timer?
Yeah.
And to put your Assie's link up on the screen?
I'm not ready, but you can go for it. Yeah, I will eventually.
I guess you get a little bonus time while he figures himself out.
Yeah. Go.
All right. I have my timer here as well, so that's fine. Yeah, I'm here to talk about OpenTelemetry Collector. I thought about putting some slides together, but I'm not, because I want to focus on what I think is the most important part of OpenTelemetry Collector. So for those of you who want to try OpenTelemetry Collector, there is a link here, right there. There are some cookbooks that I prepared for over the past few years, and they show you how to do very specific things with the OpenTelemetry Collector. Now, when I think about OpenTelemetry Collector, of course, the idea of vendor neutrality for an OpenTelemetry comes to my mind. And what it means is, so we have several dimensions to vendor neutrality, right? So one of them is OpenTelemetry Collector is not a project that is maintained by one specific company. We have a few people from very different companies on a daily basis maintaining the project. So if you think about any big observability vendor, they're very likely represented among the contributors and very likely of the maintainers of OpenTelemetry Collector. OpenTelemetry Collector is very versatile. So we split into what you called out earlier with me. So we have receivers, processors, and exporters. We also have connectors. So connectors, they connect pipelines. That gets a little bit more advanced. And you can learn about connectors on the link here down there. But the idea is indeed what you mentioned before. So we receive data, and data here can be logs, metrics, and traces. We do some processing on that, so we can remove PII. We can do some of those regex parsings that were mentioned before as well, and we can convert signals, right? So perhaps we have like logs that are just repeated all of the time, so they're all the same. Perhaps we can convert those text strings, like those huge text strings, into a metric, into a counter. So now we have a way more efficient way of counting how many times that single event has happened, right? So we can do that kind of transformation at the collector. The idea being that I don't have to touch my application to transform the data, the telemetry that is being produced by that application. Sometimes I don't even have the source code for that application anymore. Sometimes that application is deployed across like hundreds of pods, and I really don't want to reload my like hundreds of pods at once just to change my telemetry. That makes no sense. So I can apply a rule to the collector, and the collector would then apply that transformation for me while the data is being processed. Of course, it's better to do the transformation at the origin, but the collector can also do that for us. It's very common to have several layers of collectors. So you can have a collector that is very close to your site, to your workload. And you can have like a collector that is local to your cluster, and then you can have an observability cluster on a control plane somewhere, so you can send data there. And at each one of those levels, we can apply the sampling strategies, for instance, so that we only send out to the next level the information that we really care about. And then from there, we can then send data to our backends. So this is the collector in a nutshell. But again, to me, when I think about OpenTelemetry Collector, what I think is vendor neutrality. So not only on the vendor side of things, so not only we have many people from different vendors helping with the project, but we also are very welcoming to vendors coming into the project and adding their own components in there. So you're going to find proprietary exporters and receivers, typically not receivers. So observability vendors are not very keen on providing receivers for their proprietary data, but they're very keen on providing exporters. But so we have, but it's okay. I mean, what it means to us is we acknowledge that new startups may be created tomorrow, and we want them to be part of the community as well. So we are very welcoming to that. We have kind of rules to ensure that the collector is neutral. Another dimension for vendor neutrality is, of course, OTLP, the OpenTelemetry protocol. Right, so OTLP is supported natively. The data that flows through a pipeline within the collector is OTLP native, meaning that we receive OTLP data, we process that OTLP data, and we can export OTLP data. Not only, so we can receive Prometheus, but then we convert data into OTLP internally at the collector, so it's invisible to users, and then we transform again into the output format, which could be OpenTelemetry, or it could be Prometheus as well. And with that, I think I'm done talking about the collector.
Excellent. That was wonderful. Thank you so much.
Wonderful.
And we'll see you shortly for the questions. Bye. All right. Now we're going to bring Eduardo on next. Just a reminder, everyone who's watching, to please ask your questions. Don't be shy. I'm writing some questions down as we go. Yeah. All right. Here we go.
We know who you are. We have your details. Ask questions, or there will be trouble. Okay.
Oh, we're resorting to threats.
Eduardo, go.
Hey, thank you. So let's get started. So I'm going to present Fluent Bit, and for who's familiar with the CNCF, you might hear about Fluent D. So Fluent Bit is a project under the Fluent D umbrella as of today as a graduated project in the CNCF. And as you can see in the landscape, we are together with Jaeger and Prometheus. And shortly, I think that OpenTelemetry is going to be at the same status as graduated. One of the goals of the Fluent ecosystem is to have a flexible tool that allows you to interoperate and provide you, vendor agnosticity in your own environments. And of course, Fluent allows you to implement what is called telemetry pipelines. Imagine that Fluent is a solution that allows you to collect many data sources with multiple destinations, but also allowing you to do processing in the middle. And for who's familiar with Fluent Bit, Fluent Bit is a C version with extra powers on top of reading of Fluent D. It's multi-thread, it supports asynchronous I/O operations, and have a very good design in terms to consume very low CPU and very low memory. And also in terms of extensibility, it allows you to extend the behavior with connector sources, processors, either written in C, Wasm, Golang, or Lua, any of those languages. And when you think about connecting data from source to destinations, this is the gap that Fluent Bit solves in general. And it can deal with different types of sources, different types of formats, and deal with different formats expected by destinations. And the way that you deploy this telemetry agent could be in your own IoT device, your own VM, your own container, or bare metal machine, and allows you to take this information out from the application and send it out. And in a normal deployment, you can have also one agent send the data to multiple destinations. And this is useful also in other environments where sometimes you want to have a single agent being like an aggregator, or sometimes called a collector, where you receive data from other endpoints and be able to send this out. In terms of interoperability, which is really important when we talk about logs, maybe it's kind of a solved problem, but when we talk about metrics, most of the industry is using Prometheus metrics format, while the other part of the industry is maybe moving to OpenTelemetry metrics. Fluent Bit allows you to seamlessly connect all the source of information and do all the translation layers that are needed. So, and the story is, and this is a question that we always get, Fluent Bit and OpenTelemetry. OpenTelemetry is a specification of a data format for different type of signals that Fluent Bit fully supports. And maybe the comparison, as Whitney said, and Jurassic was like, yeah, Fluent Bit is kind of similar to what the OpenTelemetry collector is, but we are an OpenTelemetry compliant agent. And also you can use Fluent Bit to connect all your OpenTelemetry applications. In terms of highlights from the project, from a very high level, it has been designed with three concepts in mind: higher performance, low resource usage, and with a pluggable architecture. And high performance and low resource usage is really interesting. If you have two cars running at the same speed, you don't care about the speed at that moment. You care about which car can consume less energy or less gas, and that is Fluent Bit. In terms of extensibility, allows you to connect to multiple sources, as I said a couple of times, and it allows you to interoperate with new formats, new protocols, and new mechanisms to communicate. And in terms of signals, the type of telemetry data, we can support logs, metrics, and traces. And at the end of this month, we are launching profiling support, which is the beta on OpenTelemetry side, and a new one that we call blob, or large binary files. This is really interesting use case. Imagine that you have these autonomous cars recording videos, and you need to have those videos in the cloud. Fluent Bit is able to process those files now. It supports multi-threading, very capable to take use of your resources. We can do metrics processing, metrics scraping, and deliver those metrics in a native format. But also you can extend Fluent Bit behavior through the configuration doing Lua scripting. Lua is a very similar and simple language that you can configure in your files. You can connect the dots between the old system of log records and convert them to OpenTelemetry if that is your strategy in your environment. And also it allows you to process the information if it comes in an OpenTelemetry native format. And as a last point, yeah, Fluent Bit is default in Kubernetes environments, and our goal is to keep being the vendor-neutral solution that allows you to interoperate with other CNCF projects and stuff that exists in the market.
5 minutes up.
Thank you so much.
You did it.
That's just such a joy. Yeah, all right. That was wonderful. I learned a lot. I have a lot of questions, and we're getting some questions in the chat, which makes me so happy. Thanks, y'all, for that. And now, last but not least, one more. Are you ready, Victor?
Go.
Okay, 5 minutes, brace yourself. So what is logging operator main objective is that Kubernetes has log resource as shared resources. They are sitting on the node, and if you are not an administrator, you have hard time to access it. So logging operator is not an agent like Fluent Bit or OpenTelemetry collector. It's built on top of them, abstract away the complexity of the low-level configuration. So it concentrates on the what, how, and where questions. And it enables the logs to be treated like true Kubernetes resources. How it works, on the collection side, there is a daemon set, currently Fluent Bit, sending everything to an aggregator, currently Fluent D or syslog-ng, routing the different kind of logs to different pipelines, doing the plugin, parsing, etc. And after that, sending them to the destination. And resource-wise, it's very simple. You got a flow resource, have a name on it. You got a match expression, select all the logs that have a pod labeled app nginx. We know that they are nginx logs, so let's apply a parser that parse the nginx log nicely. And after that, just put them on the forward output. On the output side, we have the generic configuration, like in an S3 bucket or region, and of course, credentials for the authentication. During the 6 years of logging operator, we had a lot of challenges, but I want to highlight one is the noisy neighbors, which is especially bad if you have back pressure. It can cause the whole pipeline to stop, even if one destination is wrong. And the other one is multi-tenant use cases that's emerging in the Kubernetes community, that you are using a Kubernetes cluster with multiple teams, multiple customers, and so on. And while logging operator is capable to handle these kind of stuffs, it's become a bit ugly. So it's very complex to operate. It can be done, but it's very complex. So we decided to sit back to the table and start a new project, scope it down. So we will concentrate on routing on the edge problem. So don't transport everything to an aggregator, and try to eliminate the noisy neighbors, and invite tenant as a first-class citizen in the system. And of course, OpenTelemetry collector came into the picture, which was a nice way of build things on top of. In this architecture diagram, you can see that's how much simpler it looks like with the new architecture. It has a collector, it got different tenants, subscripting to different logs, and sending to outputs. The resources itself are very simple as well. The collector is an OpenTelemetry collector settings. You can have one or more collector. Some of the users use hard multi-tenancy, pinning collectors to specific nodes, or you can have a multi-arc setup as well. The tenant defines a tenant, which is one or more namespaces selected by namespace labels. You can set two things, where a tenant can accept logs from, and where I can read the subscription for specific tenants. And the subscription level is where the tenants can configure their logging stream for themselves. So here you can decide what I want to collect from the nodes. If you have a large cluster, like thousands of nodes, you don't want to collect everything for your aggregator. You just want specifics. There is an OTTL expression that you can use to pre-filter your logs. And after that, you can set your output, which is running an aggregator running inside your tenant. So it can be, like an OpenTelemetry collector that you configure yourself. So you don't have to share the resources during parsing or other stuff with the other tenants. The output is very similar to the logging operator output. You can set the authentication credentials and point the data in the right direction. So I want to highlight that telemetry controller is not an OpenTelemetry operator. It's not comes with all the bells and whistles. It's a very opinionated and very narrow scoped project to help you manage the log collection part until it gets to the proper tenant aggregator or destination. And you can have a view about what these two projects do, but this is a very high-level overview. If you are running a multi-tenant Kubernetes cluster, you want to do the collection stuff with telemetry controller, and you can use the logging operator as a tenant in a headless mode without the collection. So you can configure Fluent D or syslog-ng, whatever you prefer for the different kinds of transformation and the rich amount of outputs that you want to use.
Thank you so much. Appreciate you. Oh, what do you mean? I'm waiting for the gong. I was like,
no, he finished just a second
finished.
before.
Oh.
Right on time.
You robbed it from me. All right, thank you so much. Let's bring everyone onto the screen. Thank you, everyone, for your wonderful presentations. I learned so much. And we have a lot of great questions in chat. So, Eduardo, you answered this in chat, but I'm going to give you a moment to address the Fluent Bit
to
versus
repent.
Fluent D. Yes, right? And pre-show, I asked them not to answer the questions in chat. And so...
Sorry about that. I forgot I should
No worries. No worries.
We're just going to publicly shame you.
Yeah.
I know.
Do it again.
Yes. Let's talk about Fluent D versus Fluent Bit.
Yeah. The thing is that Fluent D was created around 2011, and sometimes the issue with technology is not a problem, except when that technology is not able to scale, right? And when Kubernetes came out, Fluent D was kind of one of the default solutions to collect logs in the systems. But for the newest workloads that we have a few years after, maybe 2018, 2019, it was okay, but it was not good enough for what was coming, right? So at least logs are generated by companies 20-30% every year. They're increasing. So at the same time, when Fluent D was created 2-3 years later, I created Fluent Bit, but was created for embedded devices. And one of the designs in mind was low CPU, low memory, but high throughput, and be able to communicate with Fluent D. And when Kubernetes started to grow, a lot of community users started to experiment with Fluent Bit and starting to asking for features that we didn't have in Fluent Bit, but existed in Fluent D, like Kubernetes filter, tail files. We didn't support tail files, syslog, and a bunch systemd and a bunch of things. So at some point, Fluent Bit started to run at the same time that Fluent D. We were from the same project, but Fluent Bit got more traction because the workload needs and it has more vision to solve the future of the project, and that's why Fluent Bit is it's replacing Fluent D pretty much.
So is Fluent D on its way out then? At some point it'll be, or is it still maintained?
Yeah, it's still active maintained, but if you look, for example, for innovation, all the innovation is happening in Fluent Bit. Around, for example, Fluent D only support logs, while Fluent Bit support matrix traces, is adding profiling, blob support, and it becomes like a more cloud-native solution despite its IoT roots.
Okay, thank you.
What's the, out of curiosity, why is it, should, ideally, people should switch from one to the other, right? Then why would you spend effort to maintain both?
Yeah, if you look at what the big players are doing, like Amazon, Oracle, Microsoft, and Google, all of them switched from Fluent to Fluent Bit for their native workloads in their clusters. Well, not Kubernetes cluster, VMs and cloud environments in general. So there is a trend, and it's not like I'm saying, we need to convince people. Yeah, it's a natural thing, right? At some point, technology is not able to solve the problem that you have today, and you need to move on. And I think that's the nature of technology, right?
So why maintain Fluent D at all? And why not?
If I may chime in a little bit.
Yeah, it's widely used.
Yeah, great.
I've seen at users that they wrote their own Fluent D plugins in Ruby for specifically their systems. And sometimes switching those are much harder than just, operating Fluent D as it is. And if you need, performance, running a 500 node Kubernetes cluster, you don't want to run Fluent Ds on everyone. You run Fluent Bit, and you may want to use an aggregator that's Fluent D with your own specific old Ruby code that no one cares about and no one, bothered to rewrite.
Excellent. That's very helpful. I'm going to expand this question to include all three technologies. But let's talk about transformation capabilities, which actually I think I might need to take back up one step and say, are transformation capabilities something that the community's built and is something that I'm likely to get something pre-built and bring it into my system, or is it something I'm likely to write for myself? And then how do the different tools, all three of them, distinguish from each other in terms of what types of transformation is possible? So Jurassic, let's start with you, please.
Sure, yeah. So we have under the OpenTelemetry collector contrib repository under processors, we have a list there of processors. Let me copy the link here somewhere. But we have I would say 100 or more than 100 components in total for the collector, and a lot of them are processors. Now, one of them is my favorite, and it's one that was kind of mentioned before, the transform processor. So that one allows people to write OTTL statements. So that's also available in the logging operator that was mentioned earlier today. And OTTL is a language that was created by OpenTelemetry collector for transformation entirely. So it came from the learnings of Stanza. So Stanza was a donation to OpenTelemetry by a company that specialized in logging. They then created this OTTL language, and that allows people to apply processing on top of each single telemetry data. So not only logs, but traces and metrics as well. Of course, each kind of signal is very particular, so they might support more features than others. So this is the one that would shine. That would be my choice of telling people to go up and use. It doesn't have to be like that, and so people can choose like the transform processor or something that has something more built in. I think the key to the collector is its flexibility as well. So as evidenced by the logging operator building on top of the collector, people can build their own processor. So if they need like speed, they can build their own processors and build their own collectors distributions, potentially using the collector builder, and so that their transformation is done in Go, which is the same language as the collector.
Thank you. Eduardo, will you speak to transformation in Fluent Bit?
Yeah, so transformation existed from the early beginnings. We implement that through the concepts of what we call filters and processors. Actually, the processors like the evolution of our filters. I'm going to paste the links now in the chat. And I would say that majority, or maybe 80% of our transformation capabilities are around logs signal type for logs. Then we have metric selectors, metric transformations, and for traces, we have selector for traces. For example, you can discard certain spans that doesn't match X requirement. And the way to implement those are through the configuration. So the moment that you define a source or an input plugin that is collecting or receiving data, you can attach a filter and start processing that information that is coming through. but also if any none of the plugins available in our documentation, might be 30, 40, around them satisfy the needs, we allow you to write your own processing rules by using Lua in your configuration. But of course, if you want something really performant at that C level, yeah, you might end up running a plugin. But I think that as of majority of use cases now that are really complex around data transformation, in terms of with many conditionals, or they had a lot of business logic on it, they ended up doing in Lua. And yeah, the performance penalty is pretty low because of the value that delivers.
Wonderful, thank you. And how does logging operator touch transformation?
So as it uses, under the hood, Fluent Bit, Fluent D, OpenTelemetry collector, it utilizes what is it under the hood. So it's a bit of leaky architecture in that way that we like to use what is under your
That
things.
makes a lot of sense. Great, thank you. And then while I have you, Sandor, do all the tools support syslog as input?
Yeah.
Similar answer to the last question. Yeah. Yes. Quick yes. Good.
Yeah, it's a yes.
How much synergy is there between the tools? That's a great question. Am I likely? I understand. Is it true, Sandor, that I can use logging operator on top of either Fluent Bit or OpenTelemetry collector? That's correct. And how much synergy is there between the tools? Is it like, I understand Fluent Bit's more performant for logs and Otel's more designed for traces. Like, could I use some of both in my system? Would that make any sense?
So there are some, certain things that you can do or can do because, there are some interoperability. People tend to forget that OpenTelemetry is not just the collector, but the protocol itself. And I think that's the key for the future of the observability. Because if Fluent Bit speaks OTLP, OpenTelemetry collector speaks OTLP, and this is the interoperability that you are searching for. And you can do the transformation or whatever the tool does best in one case and do the other in other cases. And the key that your log will look the same because you're using the same protocol, and OTLP gives you a scheme as well. So that's a very powerful addition. And I think that's why telemetry pipelines are emerging, because OTLP is not just log, but log, metrics, and traces. You have the same format, so you can interoperable between tools and just use what's best for that specific thing.
I have a semantic question, like a vocabulary question. If I use Fluent D as a telemetry processor, is that also called a collector, or is it only called is collector a OpenTelemetry specific term?
Dangerous terrains there.
Yeah. I just want to know how to talk about it.
So the funny thing is, so I've been with the collector since it was called Open Census Service, right? So the OpenTelemetry collector on the previous generation, the previous life, it was called Open Census Service. And we thought that service was a bad name for what it did. So we renamed of course, it was an OpenTelemetry service, and then we renamed to OpenTelemetry collector. Now, it is still not a very good name. And we typically use collector as like the name of the project within OpenTelemetry that does the telemetry pipeline. Now, the word collector is now being used to denote that across the industry, basically, right? So people can use collector basically to mean that they are similar to OpenTelemetry collector in some way. So I would argue that collector nowadays is very, very well understood as a data pipeline solution. So not tied to OpenTelemetry collector specifically, but in general. And I said this is a dangerous because I'm trying to define within the OpenTelemetry community, we're trying to define what is OpenTelemetry collector. So is it like the Git repositories that we have? Is it the SIG within OpenTelemetry? Is it the binaries that we produce? Is it? I mean, what is it really? And we don't have an answer.
Yeah, in our case, for example, looking backwards 10 years ago in Fluent world, when we used to do just logging, we used to call the aggregator. The aggregator was kind of the piece that sits in the middle that receives and ship information. But if that same tool is deployed on the edge where the data is being generated, used to be called the forwarder. But forwarder also do processing in our case, right? So we also got the same problem with semantics and names. So I think that it matters what it does and where it's deployed. It's kind of a mix, and that's why the confusion comes up.
Yeah. Can you speak to, Eduardo? So Fluent Bit supports OTLP, and that's part of the synergy. Would you use different data telemetry pipelines? Like, is there a use case where you'd have a Fluent Bit telemetry pipeline and an OpenTelemetry collector in your same system? Or is that interoperability not there?
Yeah, maybe I will base the answer on users' feedback. One of the problems that exists today is that when people manage environments, they have multiple agents on the same node, right? Mm-hmm. And that's a constant pain because you have a learning curve for each one if something's not working. And what we're trying to do is to unify that experience under one tool. That's Otel Collector is doing, that's what Fluent Bit is doing. Now, from the application perspective. Now, we jumped into the metrics space. Let me give you some context because we had users that said, hey, I'm using Prometheus Node Exported, which collects metrics from the system, but also I'm running Fluent Bit. Can we implement this functionality inside Fluent Bit? Mm-hmm. And for us was like, hey, let's copy paste the logic in Fluent Bit and you just can just manage one agent. And we did that, right? So I think that it makes sense. It makes sense, and it's really interesting how these things can evolve. But around, and also taking back the same question, is like, I think that the synergy is really important. And from use cases, I think as same as this show, as having option is good. And to be honest, if you go to any production environment, you will never find just one single technology. Uh-huh. It's a mess. You have 10, 20, 30, 12. If you go to, at this, we're talking about cloud, right? When the CNCF space. If you go to talk to the banks or financial institutions, they're not running containers. They're trying, but they're not running containers, right? They're deploying very old Java applications. And anyways, you need to take that telemetry data out of it, right? And you cannot tell them, re-instrument everything with Otel. Yeah, we will take them at 20 years for them, right? So I think that it depends on the space where you're running and the solution you're trying to solve, but I think that it's good to have this synergy and different tools for different problems, but they coexist. I don't think that this is a drop-in replacement.
Right on. We still have 5 questions and we're approaching the top of the hour. So we're going to do speed round.
Lightning round. So Gerasi, what can you speak to? What's the use case for collecting logs and metrics from IoT devices?
That's a great question. So it kind of goes back to my example of having several layers of collectors. So what I've seen is people deploying one OpenTelemetry collector very close to their workloads. And IoT devices would then offload very quickly their telemetry data to a collector somewhere very close to them. And the collector would then apply the buffering, the resiliency, the sending of data, telemetry data to a central collector somewhere. So that would be the architecture that is more common when applied to IoT devices.
Okay. Is it similar in Fluent Bit?
Yeah, same case. That's why we created Fluent Bit at the beginning, because all these gateways or embedded Linux environment aim to ship data. So we were thinking about 2020, 2024, where our microwaves were shipping data like crazy. That didn't happen. But
I hate that, by the way. Yeah. I'll pay extra for a dumb appliance. Thank you. And what about, how can logging operator improve the experience of Internet of Things devices?
Yeah, if you have to manage, different kind of complex configuration and you don't want to do it by hand, that's where a logging operator can help you, generating all this configuration. Because if you want to do a lot of stuff, it becomes increasingly complex when you write the configuration by hand.
Excellent. And then what is the setup complexity of each tool? Eduardo, let's start with you, please.
I think it depends on what you want to do, and this is a generic answer. If you just want to collect data from one file, send it to an HTTP endpoint, it's pretty easy. But the moment that you start adding transformation, processing, and other things, it gets more complex. It's just a learning curve. So it could be so easy and so hard dependent of your own use case.
Excellent. There's a question about what language would you use to learn OpenTelemetry? I don't quite understand that question.
The next one is a clarification of that same question.
Great.
There
okay,
we go.
Thank you. would you choose to learn it with?
Oh, I see. Okay, that's better. I think I would probably start with one of the big four languages. So Go, Java, Node.js, or .NET. So those are the ones that I would start with. I'm a Go developer myself, but I'm the first to admit that the Go API for OpenTelemetry can be a little bit challenging at some use cases. So you can get up to speed very quickly for the basic use cases. But when you start going to more complex details, then it can be a little bit tricky. But I mean, it all goes with the language that you are more comfortable with, right? So I guess that's the non-answer to the answer. But stick with the big four, and it should be fine. We have support for, I think, 9 or 11 languages. I lost count now. But I would probably not start with like a niche language right now, because the support for OpenTelemetry APIs and SDKs is not complete for those. So perhaps guide yourself by the compatibility matrix that we have at OpenTelemetry.io.
I have a feeling, and correct me if I'm wrong, that non-compiled languages tend to mature faster, right? Kind of JavaScript. I saw, libraries and even auto instrumentation for JavaScript long before I saw it for Go, for example, right?
I mean, so that one specific example, yes, sure. I mean, Go is compiled, so adding auto instrumentation using the normal techniques is hard. For Java, we have a Java agent since the open tracing days, right? And with Java, it's easy. I mean, you can do a Java agent that does bytecode manipulation at runtime. So it's kind of easy to implement an instrumentation agent. For JavaScript, it's the same. Like you can just include instrumentation.js or TS, and all of the common parts of your application would be instrumented. With Go, it's compiled, so it's harder. The way that it works right now is through eBPF. So eBPF does is kind of like cheating and doing the instrumentation for you, but it is not at the Go level, right? So it is at the eBPF level, so syscalls level.
Are we talking about tracing right now?
No. I mean, OpenTelemetry is for everything. Oh, sorry to cut you off.
No, I mean, I didn't think that like metrics and as logs necessarily needed to have language-specific implementation. So I'm just trying to understand that part.
Can you
we're talking about instrumentation rather than implementation, right? If you want to extend your application to, correct me if I'm wrong,
to emit metrics or logs or any of it.
Yes,
and then
exactly.
How does that fit with Fluent Bit then? Do you have instrumentation for emitting application level information?
Yeah, actually, a few people know about this, but 10 years ago, we implemented SDKs to speak the Fluent protocol that is called Forward. And that has been there for, 10 years. We have, for Python, Java, C++, most of the languages. So if you wanted to ship logs over the network with an SDK, we have those tools. But we found that it was working fine, but if you depend on the network to have to secure your data, it's not the best way to do it in the high load environments. You always will prefer somehow to write this data to disk and then, calm your mind and making sure you didn't lose any data, because network fails, DNS fails, most of network fails, right? And things work fine. So but I'm not aware about any new projects on that area. And I think that I prefer to stay away from it and solve the problem from another angle.
That's fair.
Personal opinion.
One last question from chat. And how does Datadog fit in this picture? I don't even really.
I think I can help here. If the person thought about Datadog as the service and whatever, I don't know the answer. But Datadog has a telemetry pipeline product, and they acquired an open source project called Vector a couple of years ago, and they built on top of that. So it's kind of like Vector is the same kind of like Fluent Bit, OpenTelemetry collector. So they have this telemetry pipeline, and you can configure it on the UI with Datadog.
More choices. That's just what we needed. Great.
I mean, I think I myself configured like 20 different agents during my engineering
Yeah.
time.
Before we do our closing statements, is there any anything that we missed in terms of talking about the different ways these tools compare to each other that should be mentioned?
I think I do have one point that was kind of mentioned already, but I would like to stress, and that is it shouldn't matter really which technology you choose today. What matters is how easy is it for you to move out of that technology if you decide to do so. Right. So I think what Eduardo mentioned is that people can use Fluent on their setup and spit out OTLP, and people can then have an OpenTelemetry collector somewhere that receives OTLP. Right. So what is important here is that you don't chain yourself to a specific solution, and you can do that by first, of course, choosing an open source collector or an open source data pipeline. But more importantly is that you choose open protocols so that the PCs can interoperate.
That's a great point. Cool. So let's do our closing statements. We'll just go in the order that we came on screen. So Jurasi, why should we vote for OpenTelemetry Collector?
I think I stick with my main point that OpenTelemetry Collector is the main focus is on vendor neutrality. And I think having a set of multiple vendors being very active in the project is very healthy and ensures that the project has a big longevity and it's there to stay.
Wonderful. Thank you so much for being here today. Goodbye. Eduardo, why should we vote for Fluent Bit?
Yeah, in a world where workloads are getting crazy and nobody thinks about energy in general, I think that Fluent Bit is one of the key projects that think about green technology, making sure that you can solve your problems by consuming less gas, as I was explaining. So that design has been there for many years, and our goal is to continue solving the problem from that angle, moving forward from whatever it comes, no matter what type of signal in this space.
Awesome. Thank you. And why should we vote for logging operator?
So it very much depends on how deep you want to dive. If you just want to solve, collect logs, transfer them, and send to them some destination, then logging operator and telemetry controller. If you want to deep dive what is under the hood, Fluent Bit, OpenTelemetry, then that is your choice.
Right on. That's great. All right. Thank you so much. Appreciate you. Appreciate all our guests. What a gift it is to get to spend time with such brilliant people.
Oh, yeah.
And you're here too.
Oh.
So it's time to vote. Our voting is live now in the CNCF Slack workspace in the You Choose channel. And it'll be live for 3 days. So if you're listening to this broadcast before Friday, Friday in Texas, then the vote will be live and go vote. And if not, maybe just check it out. And if you're, and whichever one gets chosen is the one we'll implement in our demo next week. And next week we're going, I don't know what we're talking about next week. Progressive delivery, maybe?
Something
Cost,
related
maybe?
to observability.
Yeah, but we'll see you next week. Looking forward to it. Thank you so much.